So what I'm going to show now is what we call the in-series microservice pipeline. And in a very basic form, that means we are going to query a remote hosted database, catch the response, and transform that response by the use of a microservice, and then pipe it through to an in-series app. So in-series can actually deal with what we get here. And you heard the microservice already a lot. So what it actually is, we are going to talk about the Python/JSON environment microservice. It's a Docker container running in the backend, and it simply awaits for your data in JSON and a Python script you provide. And as soon as it gets these files, it executes your Python script and returns whatever you want to return here. So it probably is JSON again, or it's just a string or an array of data like you want. And I quickly walk you through a data visualization example workflow, a common workflow, how to do that. So what are the steps here? First, you have to have a use case. You want to do something with data. You want to visualize something, maybe a basic pie chart. Next thing you want to do is you have to acquire your data. That might be from a file or Excel sheets or local database, or like in our case, a hosted database with an API. Then you have to query the data. You will have to set up a query that retrieves the information you want to visualize, and you have to check the responses. And once you're happy with what you have, you might want to choose a tool to visualize your data. There are various tools out there to do that, or you could opt for a JavaScript library like D3 or something similar. However, whatever you choose here to create your chart, you will probably have to stick to a certain and fixed data input, so the chart will be actually displayed. And what you need here to create the chart will most likely not be the same as you get over there from the database. So you can start to write a transformation from your response to the needed data input. And in this case, we choose Python to do so. Python is widely used in academia and research, maybe like R. And it's also very accessible to non-programmers or beginners. So you might want to do that all locally on your machine to test everything out. Once you created your chart, you want maybe to add some refinements, a legend to it, and some interactions. And then the maybe harder part is then you want to publish your chart, your visualization. You can do that with static data, meaning you do all of this here once. You do the transformation once, and you keep your static input data, or you create a chart and then just publish an image of it, or HTML or PDF, whatever. All of this is done within the realm of your tool. So if your tool doesn't support this, then you have to do something else. Maybe you want to use the R Shiny server, then you should have started maybe with R here from the beginning, or you have to rewrite what you did here. And it gets even harder if you want to publish it with dynamic data, meaning that every time a user requests your chart, the newest data is pulled, transformed, and the chart is created. So you might end up with a little web project if you want to do that. And if you want to use your Python script here, you need a backend that supports Python. Otherwise, you again have to rewrite everything and set up a little website, which might sound easy, but then it will take you longer than you thought. And there is no time to do that. And what I want to stress here is that within in-series, you can actually replicate your complete local workflow in an online environment, and you can even use your own Python script. So let's use a real use case. I'm going to talk about the DeLille project again. And let's say we want to visualize the number of citations of all the verses in the poem per author type. That's our use case. This is the poem. It's rather long with these 650 verses. So we know what we want to do. All of the data about the poem and its commenters and citations is in a data set hosted on fuseki niaine.ch. The creation of that data set was part of niaine as well, which you might have heard yesterday already. So once we know where we can acquire the data, we can set up a query. In this case, it's a Sparkle query, which retrieves the information we will need. And we get back proper JSON from this fuseki instance. Next thing is we choose, obviously, Inseri to visualize what we want to do. And we just go along with the default refinements and interaction that Inseri provides with the chart. And next thing we can do is we can check the GitHub documentation about this app. So we will know how the input data has to be structured. And once we know that, we can start to write some lines in Python, which transforms our Fuseki response to the needed app input structure. And at the very end, we can then publish it in a very dynamic way, meaning that the data will always be on the hosted triple store. And you will access the chart in Inseri. So this is a bit of a recap of what we saw earlier this day. I'm going to show you all the building blocks you will need to do that. So you have to use the data management to add the query to the data source and catch the response. You already saw some examples earlier this morning. We will use the My Files app from Omnia to upload our Python code, which we developed locally. And we are going to use the Python JSON environment to communicate with the microservice in the backend. And whatever the microservice returns, we pipe through to the PyChart app to actually visualize it. And overall, we use the data management mapping interface to connect all these data flows. So next thing, I'm going to show you how to set it up. This will be a video of about 3 minutes, I guess. So at first, we create our page. This will be all faster later. So once the page is there, we open the My Files app and upload our Python code from our machine. Then we open the JSON environment with the Python code. We close the My Files app, make the rest a bit bigger. And the Python code is already there. What's missing now is the input, the response, the query. So we will add a new query and define it. So it will be a post to fuseki niaine.ch, the little query. We add some header information. We're going to tell the server that we will post a Sparkle query, and that we want to receive back JSON, please. And In the end, we grab our query, prepared query, and paste it to the body. So we save this all, and then we can try it, and we see that it works. We have useful results. And now we map this query response to the JSON environment to communicate with the microservice. So it gets its input. So now everything is there. The environment has an input, the response from the server, it has a Python script, and at the bottom you see the microservice was already called and the Python script was already executed, and what we get back is the input we need for our pie chart. And maybe the next step you already saw as well today. It's a bit more special. We are going to grab the unique ID of that app and use it to add a new query. And we do a GET request to that very app. And what we get back is the output, the input needed for the pie chart. So the last thing we do is we open up the pie chart app. And now I have to pause. And the pie chart app comes with some default data. We also heard that. Now, unfortunately, that default data is actually the same as in our demo here. So it will be a bit hard to see when the data is showing the response from our live query. But you will see that the default app, the default data uses English labels, and we create French labels. So you will see that it's sometimes changed. Last thing we do is we app the output from the microservice to this pie chart app. And it's done. Now it's switched already. And then I'm going to show you that in a live setting. The app works as expected. And you can save the page and publish it later. So this is the chart on our test instance. And you see that is the description, there's the Python code. These lines are just here to transform the response. And at the bottom, we indicate our new labels, our French labels. These are the keys used in the response from the database. And we want to say this is champ de lettres, and so on, and the output. And let's say we want to use something else here, something else. Then we can update all of that. Microservice was already executed. Our new label is now something else, and that's already piped through to the pie chart app. Another example is this thing. You saw that also with the time range. This is this huge bar chart with 650 verses indicating the citations per verse, and then we can change the ranges of the years of the citations. And this also works, for example, with a microservice. We have a response from the server. We have a bit more Python lines to transform this. And then just for demonstration, this chart has a lot of data points, but they are getting piped through quite nicely to the chart app, so it can deal with quite a lot of data. And the only programming you actually need to set this up is the Python script. The rest can be handled by Inseri, and it maybe takes you 5 minutes to set it up. Another example. Now my
it's because
browser.
of the zoom option bar. You have to. Yeah, it's always in the.
Okay, or maybe
it's
I
not
close these
common.
away.
Yeah.
So that's not here. You also saw that, Roberto showed that already. That's the actual poem with the verses. And actually, we also use the microservice here to create the text, the HTML. So we also have an input. We have a graph of all the literals of the verses and then endnotes, and we can query all of that information. And then in this case, I used the Yatak Python package to write HTML, which are a bit more lines, but then our output is, now my screen is useless. Sorry, I think that's because of the Zoom performance. But we actually can create not only data for visualization, we can also deal with text and create HTML. And in case you can prepare any input for any app by using this microservice. So I stop this and I give back to